Hi everybody, welcome to our new show called Science of Tomorrow, where each week we talk about a new and interesting science subject that may change our life in the future. So today we will be talking about biofuels. So firstly, what are biofuels, Lizzie?
Biofuels are combustible fuels made from biomass and used in replacement or additive to transportation fuels like diesel or gasoline. So the energy created by their combustion is converted into mechanical energy to make the car go forward.
Okay, so this is biofuels, but there are many types of biofuels that exist. There's three generations. So the first generation of biofuels is made using food crops such as sugarcane, maize, corn, soybean, and canola. They're created using conventional techniques of production. But since they are made using food crops, many people question if it's right to divert food from the global food market in order to produce fuel. The second generation of biofuels is made by using cellulosic materials such as wood, grasses, and inedible parts of plants. This technique makes them is a little bit more complicated since those types of waste is a bit more difficult to break down during the fermentation process. So thus they need to be treated before they can be processed and transformed into biofuel. The third generation of biofuels is created using the lipid production from algae. Algae has the advantage of being a low-cost, high-energy and renewable crop. It also seems to have the potential to produce more energy per acre than conventional crops, and it can also be grown using land and water unsuitable for agriculture. So, Mehdi, often enough we heard that we can't just put biofuel in our engine and we need to mix it with renewable fuel. So why is that?
So we can't choose biofuels by themselves because when we use them, they're gonna freeze because of the air temperature. They have a freezing point higher than zero, so we need to add regular fuels that have freezing point lower than zero to lower their freezing point, and thus they can be used.
Okay. So now, in general, we want to use biofuels because it would reduce the effect of climate change and global warming. But what exactly do those two terms mean? Well, the difference between the two is that global warming refers to the long-term increase of the global average temperature of the Earth due to the fossil fuel emissions. So it has been proven that the global average temperature began to increase during the Industrial Revolution, and the Earth is now 1 degree Celsius warmer on average nowadays. And climate change, it will refer to a broader range of natural phenomena happening worldwide due to the burning of fossil fuel and release of heat-trapping gases. So these phenomena are like the rise of the sea level, the melting of ice in Antarctica, Greenland and the Arctic, extreme weather events, and the shift in the blooming of certain plants/flowers. These are all phenomena related to climate change. So Mehdi, once the carbon dioxide is in the atmosphere, how long is it going to take to disperse?
So first I would talk about where it goes. So it goes in the ocean, but it takes around 20 to 200 years, and it's only about 65 to 85% of the CO2. So we don't exactly know that.
Okay. Very good. So us here at Science of Tomorrow wanted to challenge ourselves by making biodiesel for ourselves. So we did a little experiment, and today we're going to present it to you. So firstly, what we did was the cleaning of the biodiesel, and for the experiment, the material needed was 2 NMR flasks, each containing the necessary biodiesel, a 100 ml graduated cylinder, some access to tap water, and an extraction flask. To obtain a clean finished product, we firstly had to separate the glycerol from the methyl esters. So the glycerol is basically some fat that is going to turn into soap, and the methyl esters is the biodiesel, what's going to be useful to us. So to do so, since the glycerol is going to stay at the bottom of the flask, we simply had to decant it into a graduated cylinder. Then we took the exact volume of the biodiesel and we transferred it into an extraction flask. Afterwards, when it was all in the extraction flask, we added a bit of water 20% of the volume of diesel in water, so that will clean the rest of the impurities, and it will be taken out afterwards. So the flask will be rigorously shaken for 1 minute, and then the solution will rest for the following days. So here's some pictures of the solution. So Mehdi, could you tell the audience how we did the combustion of fuels?
So with the biodiesel we produced, we make an experiment to know how energy it will create during the combustion. So what's going to happen to make mechanical energy. So we took 250 milliliter of tap water and we poured it in soda can. And under the soda can there was a burner with different fuels. So we did biodiesel, diesel, and ethanol. The temperature was measured before the burner, and we let the burner burn for the time it took to increase the temperature of the water of 3 degrees. Afterward, we waited the burner because we waited before and after to know how much mass burned, and it gives us with some calculation the heat of combustion of all the fuels.
Okay, so here's a few tables presenting the results that we got from our labs. Here's the table of the stoichiometry of virgin soybean oil. We can see that 0.16 moles of biodiesel are produced. Here we have a table of the percent yield of soybean oil and used oil. We can see that soybean oil has a percent yield of 98%. Here's the table of the theoretical energy content of various fuels. We can see that octane has the highest heat combustion with 47.9 kilojoules per gram. Here's a table of the burn mass of various fuels. We can see that ethanol has 0.58 grams of burn mass. Here's a table of the water temperature variations. We can see that there's a 5.1 degrees Celsius variation for ethanol. Here's a table of the heat combustion of various fuels. We can see that a biodiesel with soya has a percent rate of 38.1%. Okay, so now let's discuss about the different results we got. So for the decline of the oils, the percent conversion of the used oil was 96.4%. And this is slightly lower than the percent conversion of the soybean oil, which is 98%. So why is it like that? Well, we think that it would indicate that the soybean oil, obviously it contained more biodiesel than the used oil in order to give a better yield. And since the used oils were used for cooking before, they already have more triglycerides that are broken down into free fatty acids by reacting with the water during the cooking process. So thus, if it has more free fatty acids, the used oil will contain a smaller amount of triglycerides, and it will also produce less metal ethers. And also the extra free fatty acids contained will react to create a small amount of soap, and this will also decrease by a bit the biodiesel yield. So during the experiment, there have been some errors, and notably maybe the biggest one was that there might have been a small fuel loss during the decanting process. So some metal esters could have been transferred with the glycerol, and that's because both of them are very similar. And to resolve to that, to solve this problem of similarity between the two phases, we thought that we could find a way to highlight the glycerol or the biodiesel so that we could better distinguish them, and this could be done using an indicator that would color the metal esters or the glycerol.
So the results of our conversion of fuels tells us that octane it has the highest heat of combustion, 19.6 kilojoules per mole, This is confirmed by the theoretical results and the fact that octane has the longest carbon chain, so it will create more energy by separating its atoms. And the other results we obtained from the experiment are confirmed by the theoretical results. Indeed, they follow the same order, and yes. However, the experimental results are the half of what we around the half of the theoretical results. So maybe some energy have been lost during the process. It could be because of the aluminum foil around the burner, all the energy that could have been in the air because of the temperature. So because of that, we can think that the errors we did all that influence on our results are the loss of energy and the reaction time, because when we see that the temperature is 3 degrees higher, we took some time to put the cap on it could have blown a little bit more than we wanted.
Okay, so thank you for tuning in, and we hope to see you next week to talk about how efficient is algae biodiesel compared to the fuels that we've seen today. Thank you.